Hi guys, good morning or afternoon, depending on when you're watching this. Um, Today we're going to talk about our Module 3, Lesson 1. We're going to be beginning to look at some area and perimeter models. This is not completely new information for you. I know that in 3rd grade, you guys worked a lot on area and perimeter, and we use area model a lot when we're talking about multiplication. So today we're going to talk about some equations and how we can determine these equations for area and perimeter. Okay, so we're going to begin with this rectangle that you see on the paper in front of you. As you notice, it's on graph paper, and so I can count up my units and I can figure out the dimensions of this rectangle. So if I were to count this side, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 units. So I'm going to mark this with a 9, a little darker. Okay. And if I were to walk across the top, I have 1, 2, 3, 4, 5, 6, 7 units. So I'm going to mark that with a 7. Now, because of what I know about rectangles, I know that opposite sides are equal in a rectangle. So I know without even counting that this side is also 9 and this side is also 7. So when I remind myself of perimeter and what perimeter is, I remember that perimeter is the distance around. So it's like if I were walking along this line and I walked all the way around, how far would that be? How far would I have walked? Well, if I start at this corner and I go up, I've walked 9, and then I've walked 7, so plus 7, and I've walked 9, and I've walked 7. So to walk all the way around this rectangle, I would walk 9 plus 7 plus 9 plus 7. Okay? Now if I were to imagine over here that I have a rectangle and I don't know the dimensions of it, okay? Pretend my rectangle was perfectly square, as it should be. I don't know these dimensions of this rectangle, but can I come up with a formula that could help me? Well, if I call this my length and I call this my width, then I know that my perimeter is, I could fill in my opposite sides too, just like I did over here. My perimeter, if I walked all the way around, is L plus W plus L plus W, or length plus width plus length plus width. So I'm going to write that here with my variables. Okay. Now let's take this even further. I'm noticing, and you probably are too, that there are 2 9s and 2 7s because we have a rectangle here. Okay? So another way that I can write this is that I have 2 times 9, because I have 2 9s. Put that in parentheses there just to remind myself. So I have 2 9s, and then I also have 2 7s. Okay, so let's think about this. We have 9 plus 7 plus 9 plus 7. Isn't that 2 9s plus 2 7s? It's the same thing, isn't it? And then even further than that, we can think about the fact that we have, grab some color pens here. Okay. We have some different ways we can look at this even more. So if I think about this 9 side here, just putting in orange, and this 7 side, I'll put some blue up there. If I were to take and think about my 9 and my 7 together, so in this case that's 16, don't I have 2 groups of that too? I have 2 lengths and widths together. So I have a length and a width, and I have a length and a width. I could group those too. And so I can also think about my perimeter as 2 times my length plus my width. So 9 plus 7 times 2. Okay, we'll come back and solve all these in a second. In the same way over here, I have two L's, don't I? I have 2 times L plus I have 2 times my width, or W. I can use my parentheses to help me with my order of operations there. In the same way, I could look at this L and W as a group together. I could add them together first. So I have an L plus a W and another L plus a W. I have 2 of those. So my perimeter is 2 length times width. So 2 of those. Okay? So in thinking of solving this, 9 plus 7 plus 9 plus 7, some of us might use some of our strategies of grouping here. So we might say 16 plus 16. So that is 32. And 2 times 9, we have 18 plus 14, also 32. And if I have 9 plus 7, I have 16 times 2. I also have 32. This equation at the bottom is what your math module is going to have you looking at the most today. But as you can see, all of these strategies work. Okay? So now moving forward, let's look at some examples from your problem set today. Okay, I'm just going to put some up here that we'll practice using some strategies. So I'm going to move this one out of the way. So in your problem set today, as you do some practice at home, you're going to be asked to find the perimeter and the area of each rectangle. So let's start with B here. Okay. So for our perimeter, we have 8 as our length and 3 as our width. So we know opposite sides, again, are the same. And if we use that equation that we learned, that 2 times the length plus the width, I know that I can do 2 times 8 plus 3. Okay, for perimeter. So 2 times 8 plus 3. So 8 plus 3. Okay, so I'm thinking about 8 plus 3, 9, 10, 11, right? So we have 2 times 11, which equals 22. So our perimeter is 22. And don't forget to label with your unit, centimeters. Now when we're looking at area, we're looking for that space inside. Okay, we didn't talk much about area on the previous page, but that would be all those boxes on the inside, the square units. In this case, we'd have square centimeters that are on the inside here. Okay, we're looking at area. If you remember from our area model from multiplication, area is length times width. Okay, so we're going to be using our length times our width, which is 8 times 3. We know our multiplication facts, right? We should know our multiplication facts. So 8 times 3 is 24. It's not 24 centimeters because we have square units on the inside. So we're going to be using square centimeters or centimeters squared. You can write it either way. Okay? Both of those ways work. Okay. Now let's look at something that's a little trickier that you're going to see in some of your work as we come together tomorrow, okay? We know in our math program, oftentimes, there's unknowns, okay? So I like to switch it up on you. So if we look at part B here, okay, they didn't give us the measurement of one side. Now this looks like a square to me, so I can infer maybe it's the same, but I'm not positive because they haven't told me that. Okay, so I know my perimeter, the distance around the whole thing is 1,000. So some people might say that 250 meters plus 250 meters, right, is going to get me half of my side, so that's 500. And then I have 500 to split between my other sides, okay? So you might see already that we're working here, that this is going to be 250 as well. Okay, but if we look over here at A, we have 120 to get all the way around. Okay, I know I have a 20 and a 20, but I don't know what the other two sides are. So if I think about my perimeter, I have 20 plus 20 plus x plus x. So that's 40 plus 2 x's, right? So 40 plus 2 x's. So I have to figure out what's on these other sides. The total is 120. So I'm thinking to myself, I have 120. I've already used up 40 of it with 2 of the sides, which is 80 left. Okay, and I have 2 equal sides that have to equal to 80. So 80 divided by 2 is 40. So I've just determined that my side x is 40 centimeters. So it takes a little bit of problem solving on this one. Great, well, hopefully that was pretty straightforward for you. I'm going to ask you to go do the exit ticket, the Go Formative exit ticket at home. See if you can solve those on your own. And tomorrow we'll be in our strategy groups to work further on this area and perimeter. See you then.